Hi Ken, I am learning about resistor, and everyone say resistor is simple, nothing special to learn. I think you can help to understand more about it.
Before I answer, I want to know how do you understand it?
With a 1 ohm resistor, the lights are bright, and the electrons move fast. When the resistor value is increased, the light dims, and the ampere decreases. I understand that, resistor using for limit the flow of electric current. Resistors are round and small, so color codes are used to show the value. Resistor values are usually standard values, first and second digit like as 10, 15, 22, 33, 39, 47, 56, 68, 82. And then with the multiplier and tolerance we got resistor value. Relationship between current, voltage and resistance according to Ohm's law. When resistors is connected in series, equivalent resistance is added. When resistors are connected in parallel, the equivalent resistance is reduced. With many formulas and relationships, I don't think resistor is simple.
Hey Yuna, I see you did a lot of research on it, very good. You understood everything so well, I don't think you need me help about it.
Just one question, what is the resistor used for?
As you said, resistor using for limit the flow of electric current.
No, I mean why? Why do we need current limiting?
As before, related to reality. Think of electricity like water.
I can imagine the resistor as a filter on the pipe. If you install two filters in series, the resistance value will increase, the water flow will be weaker. When connecting the filter in parallel, the resistance value will decrease, and the flow will increase. That's all, and is it missing something?
Suppose to build a water system for a farm. Each area requires a different supply water pressure. For different water pressures, we have to build 3 water tanks with different heights. It is not necessary to build many water towers with different heights. Instead we should reduce the pressure by increasing the resistance and reduce the flow. Electrical devices also have different voltage requirements. For example, the main power to the circuit is 12 volts, if using lead 2V directly with main power, it will burn it. Simple way is to use resistor to reduce voltage on device.
I think one better make electrical devices with same voltage as mains voltage.
Yes, with industrial equipments they use 24 volts same for control signals.
If the devices use the same voltage, we don't need the resistor anymore.
In electrical circuits, we needs devices that work with low power consumption. It is difficult to make devices that use high voltage but low energy consumption. So LED is made with 2 volt, or IC also has low voltage, and many different voltages suitable for power consumption. So we still need to use resistor.
How do the resistors help reduce the voltage to match the device?
When not using a resistor, the voltage directly at the bulb is 12 volts. When I increase the resistor value, the voltage at the bulb decreases. When the resistance is 50 ohm, then the voltage at the bulb is 2 volts. Example, R2 is the load, and R1 is the added resistor to drop the voltage. The voltage across the load will be proportional between R2 with total resistance. Similarly, when connecting a potentiometer with 10V, we can adjust the Vout value from 0 to 10V. The flexibility to change the voltage across the load, by changing the resistance percentage, is very convenient. We can use this to change motor speed through inverter, and other applications.
Resistors are interesting and useful, so with 24V DC power source and resistors, I can drop the voltage and make power source 12V, 10V, 5V, 2V.
Hey Yuna, resistor is not such a miracle, it can change the voltage across a load of a simple circuit, but it never become a power source.
But why? You confused me more, please explain to me.
Power source, it can supply to one load, or many different loads at the same time, but still ensure constant voltage.
If there are different loads, I believe it is still possible to calculate the right value, to get the voltage across the loads. with the same input voltage, and I will adjust the value of R1 according to different loads.
Una, you're the kind of person who doesn't give up easily. I have battery source with 9 volt. The added resistance is 10 ohms, to make the voltage across the bulb 3 volts. Una, did you think of 3 volts here as a power source?
Yes, I think so. To create the desired voltage, we adjust the resistor value.
I will try the switch on to add load. You see, the voltage has dropped. When I turn on and off, this voltage changes, so it is not stable to be power source. Now look at the battery. What happens when I change the loads? It is stable and the voltage is always 9 volts, it no matter what you change.
Ah, I thought it was simple, but I was wrong. I learned a lot, thanks.
One more thing you need to pay attention to about resistors. That is the power consumed by the resistor. I have 2 circuits with the same voltage divider, 4.5 volts. But the circuit on the right will consume more power. So the resistor in this position needs to have a large capacity, or it will burn out. With different power consumption, the shape and size of the resistor is also different. Common resistor. Chip resistor. Use small power consumption. Resistors with larger capacity will be larger in size. The role of the resistor is to reduce voltage, or remove excess energy. This consumed energy is converted into heat by the resistor and discarded. Or we use the heating power of the resistor like this device.
Okay, resistor is not as simple, and I learned many things, thanks a lot.
Never mind, see you later.
Remember to click like and share to help those in need like me. Thank you for watching.